Hi there. In this video, I'll be sharing a trick on how to convert an equation of a parabola from its standard form to the vertex form without using completing the square. So to do this, our trick is to first find a, h, and k. So how do we obtain this? First, note that in the previous video, we learned how to obtain the vertex of a parabola from its standard form. So this is given by the point negative b over 2a, and the y coordinate is obtained by plugging in negative b over 2a into this equation. So we now have a value for h and k. What's left is the value for a. But observe that in our standard form, we already have the value of a. So what we do is we simply plug this in the vertex form to obtain the a. So given a, h, and k, we can write the vertex form of the parabola from its standard form without even using completing the square. To understand this better, let's have some examples, starting with the first example. So in here we are given y equals x squared minus 2x minus 8. Before we start, feel free to pause the video so that you may try this trick first on your own. Okay, good, so let's start. So first take note that we can express this equation as 1 times x squared plus negative 2 times x minus 8. So we know that in here, 1 here represents the a, while negative 2 out here represents the b in our standard form. So we can obtain h from this, which is given by negative b over 2a, or plugging in b and a will have negative times negative 2 over 2 times 1. We can divide the 2's out here, and then negative times negative is positive, so we'll be left with 1. This is the value for our h. For the k, what we do again is we use the value of h, which is 1, and plug it in to our equation. So we'll have 1 squared minus 2 times 1 minus 8. This is equal to 1 minus 2 minus 8, or when simplified is negative 9. So our k is negative 9. This is the value for k. Observe here that we already have a value for a, for h, and for k. So we can now obtain the vertex form of this parabola. That is y is equal to, so that is a times x minus h squared plus k, or 1 times x minus 1 squared plus negative 9. Or when simplified, this is equal to quantity x minus 1 squared minus 9. This out here is the vertex form of this parabola. So as you can see, the method is straightforward. Just obtain a, h, and k. Let's now move on to the second example. So we're given y equals negative x squared minus 4x plus 1. Again, you may pause the video so that you may try this trick first on your own. Okay, good, so let's start. Take note that we can express this equation as negative 1 times x squared plus negative 4 times x plus 1. So we do this to easily see a and b. So negative 1 out here represents the a, while negative 4 out here represents the b. Given this, we can obtain h. Again, h is given by negative b over 2a. So plugging in b and a will have negative times negative 4 all over 2 times negative 1. 4 divided by 2 is 2. We can cancel out the negatives out here and we'll be left with negative 2. So this is the value for h. Next, we find k. To obtain k, we use the value of h, which is negative 2, plug it into our equation, and we'll have negative times negative 2 squared minus 4 times negative 2 plus 1. This is equal to negative 4 plus 8 plus 1, or when simplified is 5. So we have 5. This is the value of our k. Observe that we already have a value for a, for h, and for k. Using this, we can obtain now the vertex form of the parabola. That is, y is equal to negative times the quantity x minus negative 2 squared plus 5. Or when simplified is negative times the quantity x plus 2 squared plus 5. This out here is the vertex form of the given parabola. So good, let's now move on to the last example. We have y equals 3x squared plus 2x plus 1 over 3. Again, you may pause the video to try this trick first on your own. Okay, good. So let's try this one out. So take note that in here, 3 refers to A, while 2 refers to B. So we can now obtain h, which is given by negative b over 2a. And plugging in a and b, we'll have negative times 2 over 2 times 3. We can divide the 2's out here, and we'll be left with negative 1/3. This is the value of our h. Next, we obtain k. So k, to obtain this, we use the value of h, which is negative 1 over 3, and plug it into our equation. So we'll have 3 times negative 1 over 3 squared plus 2 times negative 1 over 3 plus 1/3. This is equal to 3 times 1 over 9 minus 2 over 3 plus 1/3. Observe that 3 divided by 9 will have 3 out here. And then negative 2 over 3 plus 1/3 is equal to negative 1/3. So we'll have 1/3 minus 1/3, or when simplified is 0. So k must be 0. This is the value of our k. So we now have a value for a, h, and k. We can now obtain the vertex form. That is, it is given by y equals 3 times x minus negative 1 over 3 squared plus 0, or when simplified is 3 times x plus 1 over 3 squared. This out here is the vertex form of our given parabola. So as you can see, the steps are very straightforward. So if you are not good at completing the square, or if you are good at it but you find this method easier in obtaining the vertex form, you may use this instead. As in math, we can have different methods in arriving at a certain outcome, but the goal is to find what works best for you. So to formally end this, here's an exercise that you can work on. So in here, we are given x equals 2y squared minus 12y plus z. So the steps are similar. The only thing that would be different is that, take note that since our degree 2 variable here is y, so the degree 1 variable is x, we know that what we do here is we are given x equals ay squared plus by rather. Let's fix this. Plus by plus c. And we convert this to x equals a times y minus k squared plus h. So it's fairly similar. The only thing that you need to take note is that the k out here is now inside and h is the one outside. So just difference in positioning, but ultimately the steps are very similar. So that's it. I hope you enjoyed and learned a lot from this trick out here. Feel free to comment down below if you have any suggestions and recommendations, as well as an answer for this exercise. So yeah, that's it, and that's all for this video.